Good afternoon to all again. I'd like to welcome you to today's webinar with the introduction to our managed Kubernetes offering here at 1&1 IONOS. My name is Benjamin Schmidt. I'm a technical consultant at 1&1 IONOS since over 2 years, and I've been part of the Kubernetes project team since actually the first conception of this new service. In this webinar, I will first introduce the topic Kubernetes in general. Then we will take a deeper look actually what is the managed in the managed Kubernetes. What do we from 1&1 IONOS actually are managing? Then how is the architecture looking like when you deploy your first cluster? And of course, the most important topic, I think for most, how do I actually create a Kubernetes cluster? So the individual steps to create your first cluster. Then we will talk a little about pods, daemon sets, and additional services you might see and which are specific to the IONOS Kubernetes clusters. We will talk about persistent volumes, storage classes that we have also implemented and are making available for you. And last but not least, a small demo. How do we actually use it? How is it looking from a Kubernetes perspective to deploy a service? And especially, how are we using the persistent volumes? As a small note about the knowledge prerequisites for this webinar, I will not provide an introduction to Kubernetes itself in the webinar. So the assumption is that actually all attendees have a basic understanding about what Kubernetes is and about the different concepts and resources it uses. So names like pods, replica sets, or daemon sets, persistent volumes, all these I assume are familiar to the attendees, and I will not explain those terms anymore. If you do have any questions for this webinar, we will have a question and answer session at the end, and please use the GoToWebinar question function to simply post your question there. So to begin with, I'd like to make an analogy to a poem by Johann Wolfgang Goethe called The Sorcerers Apprentice, which is actually one of Goethe's most popular texts. The magician's apprentice had wanted to ease his own life by calling brooms to life with the help or to help with daily chores. But shortly after using this powerful magic, the apprentice needs to realize that living brooms are not that easy to handle after all. So things get out of hand quickly, and the apprentice is looking for his master to get a grip on the situation. He calls out, and now I quote the actual poems, "Still they're running, wet and wetter, down the steps the water's falling. How appalling, all this water! Lord and master, hear me calling. Oh, here comes my master. Help me, Lord, I plead. Spirits I have conjured no longer pay me heed." End of quote. We might have felt the same way as the apprentice did when introducing microservices and containers into our organization. It was easy to handle when it was just a few microservices or when containers was purely a topic for developers. But with the increase in numbers of services and the adoption of containers even for production workloads, things can easily get overwhelming and hard to handle. And that's where actually Kubernetes then enters the picture as the master magician or the orchestrator of containers, finally getting a control of all those containers again. However, Kubernetes itself is not that easy to set up and manage, as I can think a lot of you have already found out. A lot of magic is happening under the hood, which is fine for as long as everything is running. But then when things get complicated, in case of a host failure, cluster failure, and that's actually when deep Kubernetes know-how might actually be necessary. Now, this is where a managed Kubernetes provider comes in handy. Instead of having to build up Kubernetes in-house, you can simply consume a Kubernetes cluster without all the operational overhead and with all the knowledge needed to run such. And that is actually our motivation for us to offer a managed Kubernetes service. But what is actually the managed inside the managed Kubernetes? We're focusing on 3 main strengths with our new product. First of all, it is fully automated. Second, fully integrated. And third, fully supported. By fully automated, we mean that the cluster is set up fully automated when it is provisioned by a user. The provisioning takes place via our usual cloud API, and you are provided with the control plane, which contains the components of the master nodes. And it is set up in a highly available and geo-redundant way. You have access to kube control. You can download that via the API. And through kube control, you have cluster admin privileges. Also part of fully automated is the lifecycle management of Kubernetes versions. So we are taking care about updates, security patches. This is not part of the beta, but will be coming soon after the commercial launch, which is planned for beginning of September. Fully integrated means that it is integrated into our existing infrastructure as a service offering, the IONOS Enterprise Cloud. It is also integrated in the way that we're integrating a persistent storage into the offering. We have implemented our own CSI-based storage classes. We will go a little into details about that later. And it is also fully integrated into our data center designer. We're currently in the final phase of this implementation, so you will see that going live for the commercial launch, as I mentioned, beginning of September. It is fully supported in the sense that we are providing the same kind of support as we are doing for our enterprise cloud. We have the team of professional services with qualified cloud consultants, which will help you move to Kubernetes, which can assist you when it comes to designing it and basically giving you advice on the architecture of Kubernetes itself. And on top of that, of course, the normal incident management process is handled by our 24/7 support team. They're also experienced Kubernauts and really offer a enterprise-grade support. Now, how does the architecture actually look like? Well, first of all, what you might know as the master nodes are all abstracted away inside a centrally IONOS managed control plane. As a user, you will not see any master nodes inside of your Kubernetes clusters. The components which are usually running inside the master nodes, such as the Kubernetes API or the Kubernetes controller, the scheduler, and the storage part, the etcd, they're each running as containers inside an IONOS managed Kubernetes cluster. This cluster itself is set up to be highly available, and it is even geo-redundant in that Kubernetes cluster spans our 3 German data centers. So it is spanned across the Frankfurt, Karlsruhe, and Berlin data center. Each cluster then has at least one so-called node pool. This is something that you provision via the API or later on also through the data center designer. A node pool is actually a concept which we have taken over from Google. They're using also the concept of node pools, which is actually a group of nodes within a cluster that all have the same configuration. Configuration in the sense of same amount of cores, type of CPU, same amount of RAM, and same amount of root storage. So you will actually not provision and configure individual worker nodes, but they will be grouped as a node pool. If you want to utilize a highly available setup, you can provision the node pools even in different availability zones. This is pictured here. We have 2 zones within each VDC, so you're free to select the node pool to the particular zone. And you can even create zones in different virtual data centers, a virtual data center even being in a different physical location. The name of the node pool that you are providing and the UUID of the virtual data center, they are added as labels to the worker nodes. And so when deciding where to place which pod, you can use the normal Kubernetes methods for this, namely labels. So you can define the pod affinity and anti-affinity rules. You can use node selectors or node taints or tolerations to basically manage where each pod or service is running, in which zone, in which virtual data center, in which physical data center. Let's take a look at the cluster details. Currently, we are deploying Kubernetes version 1.15.2. You might see changes later on. As time arises, we will certainly also offer newer versions for that. The container runtime we have chosen, it's Docker, and this is the current 18.9.7 version. And as the whole system is built on the IONOS Enterprise Cloud, we are also reusing the resources you find there. One such resource is the operating system. It's the image inside the Enterprise Cloud. And there we have decided to base it on the latest CentOS 7 image offered there. The details of the worker nodes or the configuration of the worker nodes, it's of course left up to you, to the user, to define those. As I said, as it is based on the normal enterprise cloud resources, you have the choice for the CPU architecture to choose between the Intel Skylake, the Intel Xeon, or the AMD processors. The amount of that is something you provide in the API call. Also, the RAM is defined by you via the API call, and the storage type, so SSD or HDD, as well as the size is also defined by you. Communication between the centrally located control plane and your individual worker nodes is actually encrypted via secure TLS with mutual authentication. And for the network provider, we have chosen Project Calico. It's the overlay network itself. You might know other ones most have used with Weave, I assume. Calico is very powerful. It allows also you as a user to gain access to its API. And through that, you can even, for example, define individual network policies. It has one downside. It does not provide itself encryption for communication between the worker nodes. This is why we have implemented ourselves encryption on top of that, basically as an IPsec configuration that acts as encryption between the worker nodes for the overlay network. Now to the actual doing. How do we create a cluster? There are two steps kind of as a preparation to it. They're optional. We have a new permission that is added to the groups inside the user accounts. So you need to authorize your users within the account to be able to create new Kubernetes clusters. And then you can reuse any of your existing virtual data centers, or of course, you can also create a new virtual data center. This slide is just an overview. We will go into each step in the following slides then as well. And the actual steps to create a cluster and to be able to use it then is a three-step process. First, you create the Kubernetes cluster, which basically deploys the control plane. Then you create the first node pool, and then you will be able to download the kubeconfig, allowing you access to the Kubernetes API. So let's look at them in detail. All the information you find on this slide is actually taken from our Cloud API reference documentation. So you will find the same kind of information also in our DevOps portal, which contains the documentation to the API. But just here as reference point, we have them all together. So the first optional step, as I mentioned, is to add a permission to an existing group. So the API calls, but for the API call, you basically need the group ID, and you need to patch it or use the HTTP method put. Inside the payload, you will need to provide the name of the group, although you will not edit the name, it is still required for this particular call. And you will need to add the create Kubernetes cluster parameter and set that one to true. That means all users using or inside of this particular group will have this particular permission to create new Kubernetes cluster. The second optional step is to create a new virtual data center. I guess this call is familiar to most of our customers. You will need to provide a name, a description, and the location being the physical data center. So 3 in Germany, either Frankfurt, Karlsruhe, or Berlin, or if you're coming from the UK, we have London data center, or of course 2 data centers in the US, Las Vegas and Newark. In the response, you will receive the UUID of the data center ID, please save that one since we will use it later on. Now, to create the Kubernetes cluster, we have introduced a new API resource called K8s. Again, with a method post, we are creating new object, and the only thing that is required is actually a name. The response contains the UUID of the new Kubernetes cluster. Again, save this one for later. We will need to use it to create the first node pool. And also interesting is that the Kubernetes cluster has a state. It is either in state deploying, that means it's being set up, and you will need to wait until the state is in state active to be able to create the first node pool. You can also do a simple get on this particular resource to get an update of the state. Once it is in state active, you are free to create the first node pool, so a set of worker nodes with identical configuration. The configuration is directly part of the payload. So you will provide, first of all, the data center ID, either the one that you created in the steps before or of an existing data center. A node pool has a name, and then the parameters, the configuration of the node pool, specifically of the worker nodes. So how many worker nodes should my node pool contain? That's the parameter node count. Then the CPU architecture, as I mentioned, the number of cores, the number of RAM or the size of the RAM, into which availability zones do you want to deploy your worker zones. You can also leave it on auto, which basically you leave it up to the provisioning system to select the zone for you. Then the storage type, either HDD or SSD, and the storage size applies here. The minimum storage size is 10 gigabytes. That is what we reserve for the operating system and for any other log files or any other files that are generated on the root partition. Again, here as a response, you will receive a UUID, and the node pool again has a state. It is state deploying when it's being built up, and it is becoming state active once the node pools or once all the worker nodes have been provisioned and configured. So this might take a while. It can take actually more than 30 minutes, depending also on the amount of worker nodes that are included in your node pool. So please be patient. You can continually poll the node pool resource. You can also directly poll the node pool with the appended UUID of the node pool. But as you might be familiar, we have also introduced the query parameter depth, which allows you to get a collection of items which are actually contained underneath node pools. And so you will get your node pool UUID again with the state either being deploying or active. In the final step, you can download your kubeconfig file with the resource, basically using your Kubernetes ID again, /kubeconfig. Do a get on it. It contains some metadata, but the actual kubeconfig that you can copy and paste into an own file is inside the kubeconfig parameter. Basically anything that is highlighted as red here on this slide, simply copy and paste it into your own file. Convert the \n into a proper new line, and then the file will also have the correct formatting. And then basically you can directly connect to the Kubernetes API via kubecontrol. One of the first things you will probably be doing once you have set up your first Kubernetes cluster is see which pods, which daemon sets are already running inside of this cluster. So you will see a whole lot that you are certainly familiar with, but you will also see 4 of them which might be new to you. They are shown here on this particular slide. The first one is a set of pods, daemon sets, and services actually, all starting out with the name Calico. As mentioned, Project Calico is the network provider that we're using inside the cluster to set, or it's actually the network policy engine. So it has a certain set of pods that are running there for as a controller and as a daemon set on each of the worker nodes. The second one you will be seeing is a very IONOS specific one. It's called CSI-IONOS Cloud. This is the container storage interface that we have implemented, which takes care to provide block storages as persistent volumes for your pods. It's also running as a daemon set on every worker node. Then you will see an Nginx proxy running as a daemon set. Because the control plane is set up to be highly available, we need a load balancer basically to access the control plane. And this load balancer is running on each individual worker nodes. The final one you might not be familiar with, it's called Seal. This is actually our own development, our own implementation of the IPsec daemon, which is needed to encrypt the communication between the worker nodes. Then you will also have the chance, of course, to see our existing storage class. As I mentioned, we are providing a default storage class. You have the possibility to use persistent storage within the IONOS Kubernetes cluster. We can quickly go through the individual parameters, which you will see if you do a kubectl describe storage class to it. So the default one, it's called IONOS Enterprise -HDD. It has the possibility or the parameter to allow volume expansion. That means you can also increase the size of an already existing volume. In the persistent volume claim, simply add the new size or increase the size to whatever you want it to be. And the CSI, the storage class, excuse me, will actually expand the block volume, and Kubernetes will take care of increasing the file system and mounting it at the right spot inside the pod. Then we also have the reclaim policy set to delete. The reclaim policy for persistent volume tells the cluster what to do with the volume after it has been released of its claim. So currently in the default class, it is set to delete, which deletes the volume automatically when the claim is deleted. But since this might not always be desired, you might have some data on the volume that you might still need. You can actually create an own storage class, which is simply a copy of maybe for this one, of this default storage class, and set the reclaim policy to retained. This basically tells then the CSI driver to keep or to retain the volume even if the persistent volume claim has been deleted. So in this way, you can then still gain access to the data on your volumes. When a user is done with their volume, then they can delete the persistent volume claim from the API, which allows the reclamation of the resource. The second or the other option you can set is the volume binding mode. It is set to wait for first consumer. And this mode, it will delay the binding and the provisioning of a persistent volume until a pod which is using the persistent volume claim is actually created. The other option is to set it to immediate. That means at the time you create the persistent volume claim, immediately the persistent volume is also created and attached to any of the available pods. This basically also means that the pod will need to run on the particular worker nodes on which the volume has been mounted. Then we also have a second storage class available. The first one was based on HDD storage or block volumes. As the enterprise cloud customers know, we are also offering SSD volumes. So no surprise, we have a IONOS Enterprise SSD storage class. Basically, it just edits or changes the parameter type. It sets it from HDD to SSD, thereby provisioning SSD volumes. The same kind of capabilities as in the enterprise cloud apply here as well, meaning the performance of our SSD volumes are based on the size of the volume. So the larger the size, the more guaranteed IOPS you will receive as a user. So please take that into consideration. SSDs truly make sense once you go above 100 gigabytes with your persistent volume. So now let's actually see how it is working live. I've prepared a system. It's basically a fresh installation of one of our clusters. It's based on the Kubernetes version 1.15.2. And I will simply want to show you a simple example. We're calling it Who Are You service. The service itself, we will look at the YAML definition. The first part, I'm creating a persistent volume claim, which actually utilizes the default storage class. I would not have to mention it actually in here, but for your sakes, of course, I have printed it here. The only access mode that we are supporting is read-write once, which basically means that one pod is able to access in a read-write fashion this particular volume. And you will need to define the size of the block volume. Again, here, starting with 10 gigabytes. If you're using the SSD storage class, please be above 100 gigabytes to be truly performant. The second section inside the YAML definition is then the deployment. Inside the deployment, we are creating two things, namely, first of all, the volume, and we are referencing the persistent volume claim that I had previously created directly via the claim name. The second thing we're creating is just one container, which contains a volume mount, namely specifically that particular volume that had been defined at the path data. And the last thing is we are creating a service out of that. So we want to make our deployment accessible externally. And here we are also offering a service with the type load balancer. This means that you will receive a static IP address from the system over which you will be able to access the service. Let's deploy this YAML file, and let's see how the system is creating the individual resources. We will do a watch, kube control, get all, and the persistent volume claim. We see the persistent volume claim is currently in state pending. That means the call has been going forth to the Cloud API to provision a new block volume. The Kubernetes already knows on which particular worker node it wants to run the Who Are You deployment. And so the storage class or the CSI implementation will make sure once the persistent volume is created to mount it at the correct host. This might take a few seconds. We will just give it time to do so. We'll use the time maybe also to look at the service that we are creating. I had mentioned, or I had defined, that it is of type load balancer. That means the service will receive an external IP address. I mentioned, of course, this is a static IP address. It will be reserved inside of your account. And you can also see this particular IP address then inside the IP manager if you open the data center designer. And I'm exposing this service at port 80. So since it's taking a little longer than I'm used to, we might actually go into the question and answer session already, and then I will get back to this particular example. Okay, since we might wait a little with the question and answer session, the persistent volume has now been created. We see the new object appearing here. With the size that I have defined, the read-write once access mode, and it is actually bound to the persistent volume claim or to the pods that I have been creating. And the service is also actually available. The static IP address has been reserved and is shown in the overview. So let's try to access the service. Directly with the IP address should be available on port 80. Maybe the pod needs to be created first. We might wait for the pod to get the status running. There it is running. And we can see that the service is available via the service type load balancer via the static IP address that is automatically assigned and attached to this particular host. It's a small implementation that we have done with the Cloud Control Manager inside of Kubernetes, which basically assigns a static IP address to any of the pods running inside of your, or to any of the worker nodes running inside of your Kubernetes cluster. It will also take care in case this worker node is unavailable, or you drain or coordinate, then this IP address will automatically be assigned to the next worker node. So then also during the beta, we like for you to encourage you to freely use this beta. It's free of charge. For our existing customers, this feature is already available. So simply use the API reference that I had shown you to create your first cluster. For our new customers, you can sign up through our website. Also, the link is here on the slides that we will send out. Give it a try. It is completely free for this month until the commercial launch, which is planned then for beginning of September. Of course, incidents will happen. You might have some problem with your cluster. Please use our 24/7 support for that. As reference here, you can contact them via this specified phone number or via the normal email address as well. If you have any architectural questions or want to get a deeper overview of our service, my colleague Ando Frömmel and myself, we're also here to help you. You can either, most likely, simply send us an email and we can schedule a personalized web session with you. So this was in general to the topic about the introduction, and now I will go into the questions